Hi everyone. Today I would like to solve another problem for you. So we have three conditions based on A, B, C, D, and the problem says, can you find the maximum value of C? So if you just look at these conditions, it makes sense. Actually, I start from the last one and I replace D with C in the other two equations, and let's see what we get. So we have A plus B plus 2c, just replace d with c, equals 8. And then here we have a squared plus b squared plus 2c squared equals 25. And this gives me the following two equalities. A plus b equals 8 minus 2c, and a2 plus b2 gives me 25 minus 2 c squared. So I would like to find the maximum value of c. It is possible to do so if I have some sort of inequality based on only variable c. And if you look at the right side of these two equations here, so basically both are based on c. If I can generally come up with an inequality which only involves a and b as real variable, then obviously I can form an inequality based on c. Do we have such an inequality? Well, yes, we have. The inequality is as the following, that a2 plus b2 over 2 is always greater than equal to a plus b over 2 to the power of 2. As a matter of fact, I can generally claim that we have the following inequality, that a to the power of n plus bn over 2 is always greater than equal to a plus b over 2 to the power of n. But because I don't want you to just take this as trivial, today I will prove this simple inequality here. So how can we prove this simple inequality? So we know that a minus b squared is always greater than 0. Okay? So this basically gives me a2 plus b2 is always greater than 2ab. And if so, here in this inequality, if I add both sides of it by this term, so I get 2 times a2 plus b2 is greater than a2 plus b2 plus 2ab. But sorry, I have to delete this part, it's not good. So but this is nothing but a plus b squared. So in other words, I could say 2 times a2 plus b2 is greater than a plus b squared. Okay, and in here, if I divide both sides by 4, then I get a2 plus b2 divided by 2 is greater than a plus b to the power of 2 divided by 4, which I can say, well, this is the same as a plus b divided by 2 to the power of 2. So in other words, I could simply prove this inequality. Okay, so we proved it, and now we want to make use of it here. So let's see how we can make use of it. I just need to replace a2 plus b2 with these expressions based on c. The same for a plus b. So what is a2 plus b2 is 25 minus 2c squared. So we have 25 minus 2c squared divided by 2 should be greater than equal to, and a plus b was 8 minus 2c. So there we have 8 minus 2c divided by 2 to the power of 2. And that is already basically 4 minus 2c, actually 2c divided by 2 is c to the power of 2. So if I expand this expression here, so I get what do we have? So here we have 25 minus or 2c squared divided by 2 greater than equal to 16 minus 8c plus c2. And then we multiply both sides by 2. Then we have 25 minus 2c squared greater than equal to 32 minus 16c plus 2c squared. And if we organize this inequality a little bit better, then we get 4c squared. This goes to the right side, and this also goes to the right side. Then here we have minus 16c, and 32 minus 27 is plus 7. So that is less than equal to 0. So we have to factorize this expression. Then we have basically 2c. So here we have 2c times minus a. This is a very famous factorization technique. So then here basically this is 2c minus 1 times 2c minus 7. So this is the same as this expression, and this must be less than equal to 0. So this is an equation of order 2 with a positive coefficient for c squared. So we know from basically such the graph of such equations that we always have, it's a parabola, and the direction of the parabola is basically upward, and it's always something like this, especially if we have two roots. And if the parabola's shape is like that, then the interval in which the function is negative, it is always basically between the two roots, root 1 and root 2. In other words, I can say, well, what is the root 1 is 1 over 2. If you basically put this first parenthesis equal to 0, and the second one is 7 over 2. So I can say that this the multiplication of these factors is always negative if basically c is between the two roots. So c is always greater than equal to 1 over 2 and is less than equal to 7 over 2. So as you can see, the maximum value of c is 7 over 2. So I hope that you enjoyed this solution, and yeah.